I work on the KDE project, which is a large C++ based desktop environment. It does lots of stuff. The project itself started way back in 1996 when Motif and CDE was really happening. That's why our KDE name is a bit of a joke on CDE, and we're glad to see that you can still run CDE and KDE on Solaris at the same time. I'm not a Solaris person. The reason I use Solaris at all is actually because of a couple of chance meetings with various Open Solaris evangelists at Linux Tag. At Linux Tag 2007, Roman and his compiler team were running around grabbing people, taking away their laptops and installing Open Solaris on it. Which was effective. I mean, it got me using Open Solaris, and then I noticed, hey, these developer tools really are quite nice. And they demonstrated some of them, and I realized that here was an opportunity to apply a different set of developer tools to our code base. I'm a researcher in software quality, so I like applying different tools to software to see what happens, to see what the tools spit out. For a couple of years, I've been running this thing called the English Breakfast Network, which is the KDE source code quality monitoring system. It's a glorified Perl scripts and monkeys, a glorified grep that goes through our code base and looks for silly things. There's lots of silly things in our code base. About 40,000 issues remain at last count. But you know, it's a good way of looking at your code and saying, hey, here's stuff that could be better. And you know, if you can inspire your developers to go out and take those issues and work on them, your code gets better. The numbers go down, your code gets better. That's a good thing all around. And when I saw the Solaris developer tools, the Studio 12 stuff, I thought, okay, here's another set of tools we can apply to our code base to make things better. So, looking at my slides finally, GCC is the de facto standard. Everyone develops with GCC. Everyone develops on Linux. Actually, all the world is an i386 running Linux 2.6 with GCC 4.1, 4.2 maybe, right? That's the free software landscape. Well, at least from the desktop point of view. I guess there's also another free software landscape that uses Java, but I don't know much about that landscape. So here we have this GCC using bunch, and that means that the code that ends up being produced is Linux GCC code, which is fine most of the time. Oh, now it's locked. Great. Roman. If anyone knows how to use KMDB to hack his laptop, do it now. Anyway, GCC is in its own right an impressive kind of compiler, and Open Solaris incorporates free and open source software components that are built both with GCC and with Studio. And there's lots of GCC stuff, even that lives in /user. And okay, the core of the operating system is built with Studio 11 right now. It's now transitioning to Studio 12. And the rest of the sort of the user land is a mix between GCC and Studio. Now, if we look at C++ in particular, KDE is a big C++ project, so that's our primary interest is C++. The stuff that Sun ships, the C standard template library that Sun ships, is pretty old. It's stable. It's rock solid stable, and you know that the code that you wrote in 1995 will still compile and run with Sun's STL right now. The problem is that most C++ code was written after 1995, and there were a couple of very important changes in the C++ standard in 1996 and 98. So there's a lot of code, and in particular, the GCC, or G++ STL, is based off of an SGI version from 98, 99, somewhere in there. That means that all of the code that GCC using C++ developers write is really G++ code, is really against that version of this STL. And Sun is shipping a different one. And that means that lots of code that you write that works fine in GCC suddenly blows up in your face when you throw it at the STL that Sun ships. And there's particularly, there's partial template specialization thingies, and you know, I could show you pages and pages of bizarre error messages that come out of perfectly normal looking code when you try to apply it to the Sun STL. Now, yeah, the GCC stuff is also almost standards compliant. It cuts a couple of corners here and there, and it does a couple of things that are very useful, but that the standard says you're not allowed to do. I'll go into that a couple of slides down. Anyway, so free software developers who are doing their work on Linux, on GCC, are just used to that particular stuff being available, and they like having Boost and all these other modern libraries that turn C. I mean, you need all this new stuff to turn C++ into a pleasant language to use. If you've just got the ancient base language, it can be pretty annoying, pretty tedious. So you want all this extra modern stuff built on top of it. Well, KDE 4, the current, next to current iteration of the KDE desktop, needs a really modern, up-to-date, compliant C++ library. It also uses Boost, which means that we have two reasons to require a modern STL. We need a decent STL, and Boost is also particularly picky. So if we're looking at our code base purely against the existing STL that Sun ships, it's just not going to happen. There's too many patches, too much that needs changing to make it compile against the existing STL. And a lot of the changes that we'd have to do won't be accepted upstream. And well, if it's not accepted upstream, if you're forking stuff, if you're maintaining large repositories of your own branches, of your own patches, you know, you're wasting an awful lot of manpower and effort in keeping particular bits of free software running. Boost with the existing Sun STL is possible if you really, really, really want it. But it's insane. Again, it takes too many patches, too much effort. So what we've gone and done is sort of surveyed the landscape. What have we got in terms of STL that's available? Sun, of course, ships STL port 4, and I think there's also an STL port 5, right? Both of those are based off of the Rogue Wave, or the Apache Rogue Wave C++ library. And what we've done is we've gone and taken the most recent version, or one of the most recent versions, and poked at it a bit, got it to work with Studio 12. So we've basically started our efforts by replacing the STL with a fully compliant, modern one that's thread safe, that's fully internationalized, that supports wide characters and all that kind of stuff. I mean, that was one of the reasons why we didn't go for STL port 4, is that it doesn't support wide characters. So, you know, we looked at the available options and decided, okay, we'll modernize. And running with the latest Rogue Wave C++, everything else works. And we've gone through and built that STL, built Boost, built this gigantic software stack on top of it. And because we're somewhat masochistic, we liked it. Studio 12 complains a lot more than GCC does. It complains about everything that you do wrong. Sometimes it complains about things that you're not doing wrong. But on the whole, we find that Studio 12 discovers a lot of errors that GCC doesn't. And Mark Mutz is a KDE developer responsible for security systems. And he's a Linux-based GCC developer. But his opinion is, well, if Studio complains about something, then it's really wrong, and we got to fix it. So he's got this attitude of Studio 12 is an excellent, excellent C++ tool. So in that sense, we're using Studio 12 as a lint over top of GCC. And then Roman tells me that Sun lint is even stricter than the rest of Studio, so I'm going to have to see what happens when we throw that at it. So Studio 12 is really, really atrociously strict, and whenever you do something silly, whenever you do something that's GCC accepts, Studio 12 complains. Well, so when we throw our 6 million lines of C++ code at Studio 12, well, we've been fixing it for about 7 months now. Yeah, it takes that long to fix everything because people continue developing, right? In that sense, the KDE 4 Solaris C++ team, which is 3 guys, putting on a best effort show in the evening, we're chasing a moving target of 590 Linux developers who are working hard to make the next best free software desktop. And we want it to run on Solaris as well with Studio 12. So we've got this catch-up thing we're playing all the time. So if we apply Studio 12 to the KDE codebase, we improve its portability because Studio 12 complains about everything. We improve its standards compliance. Sometimes we even improve its performance. And we're discovering design flaws as well in the way KDE applications have been set up, or data types that are, not quite right. And again, this is all stuff that G++ language, let's call it, accepts. And sometimes it can be hard to explain that particular constructions just aren't right. It compiles, ship it is an excellent way to do free software development. But it's not the only way to do free software development, and sometimes you can do things better. So in the course of applying Studio 12 to the KDE codebase, plus the giant dependency stack that we've got, we've come across a number of concrete examples of what goes wrong, what do people write down in a strange fashion. I should take a moment to say that there's been a good deal of synergy here. KDE is a big code base. We do a lot of silly things, but we also push the envelope. We do a lot of interesting things with C++, and so we push the compiler to the limit as well. And that means that since we started doing this, I've been sending Roman complaints regularly saying, this doesn't work in your compiler. When I do this and this on Spark in 64-bit mode, then that blows up. Here's a case of ambiguous overloading that Studio 12 complains about, and I still don't understand why that is so. So there's been a good deal of synergy between the Studio 12 team, who are getting bug reports from code that's out in the wild, and the KDE team, who are improving their code based on what Studio 12 reports. And well, I'd like to think that in that way we're responsible for several of the patch upgrades to Studio 12 in the past years, just from finding real-world examples for strange stuff. In defense of the Studio 12 team, it should be said that a lot of my bug reports saying this real-world code crashes the compiler, I get as an answer back, yeah, we know, it's fixed in the next release already. So, it's a balance between testing, showing errors, and real-world code also demonstrating the same. Oh, this is a bogus example. This is an example of how you can write ugly C code, C++ code, if you really want to. And it's bogus. I mean, I'm not going to say, look, you can write ugly C++ code and you can write the same stuff in a beautiful way. We all know you, or I'm going to assume you all want to write the most elegant possible code, which would be in Haskell, probably. But how many functional programmers are there in the room, anyway? All right, one over there. Good man. How many C++ programmers are there actually in the room? Four-ish. Everyone else is C? C forever? Okay, what the heck do you guys do then? Good man. I'm a Java. My research work in Athens is actually I do a lot of Java programming for that. So I understand. I feel your pain. Okay, concrete example of what goes wrong when you write an application with GCC and then throw it at Studio 12 is this one, where we've got a bunch of extraneous stuff, but the important thing is the function do-sum mismatch there in the middle. It takes a couple of parameters, and they're all non-const parameters. So you've declared this method to take non-const parameters, and then when you go and implement it, damn it, okay, part of this is these are an old version of my slides. So anyway, what we have here is another method which should have been called do-sum mismatch. All right, thank you. So here we've snuck in a couple of consts, right? We've declared the method non-const, but then in implementation we decide, well, you know, these parameters are I'm not going to change them after all. So let's write that const in there, and the compiler will complain when I do change them. So I've changed my mind. I declared it was non-const, and I'm implementing it as const. GCC thinks that's fine. And you know, semantically, it probably is okay as well. If you declare something non-const, you're saying, I might change it. And certainly for value parameters, you know, if you might change it, well, that's meaningless to the caller. Now the thing is that Studio 12 mangles constness into the symbol name. And this thing suddenly started vibrating. So what happens is that this compiles and it fails to link simply because the symbols are wrong. And this is something that GCC accepts because it doesn't mangle constness into the name. I believe it's actually a design failure. If you're declaring stuff to be const or non-const and your definition, the implementation, they should match. Because it's all about honesty in your declarations and your definitions. So that blows up at link time and not before then. Here's another concrete example of what we ran into with incomplete types. Because we're reproducing the problem code completely, it's a bit bigger than. We've got a class called subentry, and inside the declaration of subentry, we've got a map. We've using that same type. So yeah, I've got an A which maps strings to A's. And that compiles with GCC, no problem. And it doesn't compile with Studio 12, and it blows up in a peculiar way. Here's one rewrite to change all of, where is it? Here's the same sub-entry and the same map, except now all of a sudden I'm using a pointer type instead of the original object. So the problem here is that the GCC STL makes an implementation choice to handle maps, a map with an incomplete type. It uses a pointer, and there's a pointer somewhere inside the implementation, and because of that, this problem code compiles, and the Sun STL and the Apache STL don't make that implementation choice. And in fact, the standard says that the incomplete element types are not allowed. So GCC has made an implementation choice that expands on what the standard allows and makes life more pleasant for developers, because they can do stuff like making a map with an incomplete type. Unfortunately, standards aren't here to make life pleasant, are they? They're here to make you do the right thing when you're coding. So that's one of the issues that we have to go through and fix eventually. Happy constructors. I don't know, there's this particular subset of C++ developers that likes typing things more than once. And I call them happy constructors. Here's just a class with a couple of constructors. The details of that aren't all that important, but what happens is that these C++ developers write this to call the constructor of a string, whereas this bit here is superfluous. So instead of calling the constructor of a class A as A, they call it as A::A. And I'm sure if you get really super happy constructor people, they'll go A. And then they start sounding like Canadians, and then we're lost. So the way the compiler interprets this is a partial constructor definition. And I mean, the difference between that and that is obvious. And this is the right thing to do. But GCC accepts the top version. Because why isn't a constructor just a static method of a class? Sure, you can look at it that way. It's stretching the definitions of the language. So again, this is something that Studio 12 helps us find these things, complains about it. The KDE on Solaris team recognizes this kind of error message coming from Studio and says, oh yeah, happy constructor. We fix it, we push it upstream, and nobody's the wiser. And then at some point, we hope to actually educate the people doing these things. Right? It's kind of tricky finding the right balance between complaining about somebody else's code and educating them. We are, after all volunteer free software developers. We're doing this because we want to do it. And the last thing you want when you're happily coding something that you enjoy, that you think is important, that you enjoy doing, is some guy coming up to you and saying, your code sucks, because some corporate monolith has produced this annoying tool that is actually C++ compliant, and it's complaining. So we have to be careful that way, not to discourage people all too much. GCC, G++ is also a lot more lenient on ternary operators, on the kinds of type conversions that G++ will do in a ternary operator. It's a little more creative. It's also a little more flexible in that it'll cast either branch. Either the bar or the foo can get changed. So there's lots of ternary operator uses where there's ambiguous casts. You can either turn this one into that, or that into this one. And Studio 12 complains about that kind of ambiguity. Studio 12 will say, well, I don't know which one to choose. GCC just makes a choice and gets on with its essential business of compiling the code. So again, this is a trade-off between convenience for the developer and correctness. It isn't always like that. Like this one. I mean, there's a missing dot there, right? Abs and lots of floating point methods are defined to operate both on floats and on doubles. And if you feed it an int, well, which is it going to be? Is it going to promote to float, or is it going to promote to double? The standard is ambiguous on what's possible there. So it complains like that. Something else some C++ developers like to do anyway is include standard bool. This is an example of basic C99-isms. GCC mixes in all of C99 in its C++, whereas C++ is based on the C98 standard, right? This kind of itty-bitty annoying things is sort of what chews up most of our time, actually, is, yes, you have used a C99 math function, like finite, and we have to map that back to what it would have been in C98, which is inf. I may have the two backwards here. So we spend a lot of time, sort of making code a little more backwards because it's got to be compliant with this slightly older C standard. Yeah, so the math is actually one of those most annoying bits because, math.h defines infinity and it defines nan. It's just a regular C define. And doing it right in C++ means using numeric limits, which is that. Again, this is one of those, there's an easy way of doing it, which is include math.h and use infinity. And then there's the right way of doing it. And you get the whole education thing again. So why are we doing all of this? Well, because we like correct C++. I like beautiful code. I like correct code. I like standards compliant code. And so that's why we like to apply this Studio 12, this atrociously strict, annoying, picky compiler to our code base. Simply because that gets us better C++ in the end. Less convenient C++ sometimes, but better stuff. So, you end up learning that good object-oriented programming with C++ is not a nebulous art. It's not something you sort of throw over the wall and the compiler chews on it or not. You really can do good, structured, standard C++ development. And it's really nice that then we get this constant feedback between the specification of the language, the implementation of the language, and the way we're using the language. And yeah, so what have we reached after 7 months of mucking about? We've basically rebuilt the complete software stack, this complete C++ software stack on Solaris, starting from the standard library, and then you've just decided to replace the standard library, and that means that everything else that uses C++ has to be rebuilt as well. So we've updated PCRE, which has C++ bindings. We've updated GStreamer, which has C++ bindings. We've updated OpenLDAP, because that has somewhere in a obscure corner has. We get this great dependency avalanche. We've updated Kerberos, just in case, just if you're feeling bored, go out and update Kerberos, which is 1.4 as shipped in Solaris 10. Update it to 1.6. It's an interesting exercise. You know, so we've got this whole avalanche of updates. An FFmpeg, I was actually going to kick Roman for being an FFmpeg person, because that's one of the most annoying bits to get right. Simply because, you know, audio AV codecs and that kind of stuff, it's an awful lot of fun to slip in GCC inline assembly, which is fine. I mean, if you're a i386 Linux GCC developer, inline assembly is fine. But unfortunately, i386 assembly doesn't work very well on Spark. And because we're committed to producing this entire software stack, both on AMD 64 and on Spark hardware, we get annoyed at inline assembly. That's i386 only. So anyway, what have we got? We've updated this entire free software stack. We've built Qt, which includes WebKit. WebKit is the sort of the new HTML rendering stuff that's coming out of Apple, which is what runs Safari. So it's in this sort of roundabout way, we've now got Apple contributing code back into Solaris, which I think is kind of funny, especially when they start sending patches that fix Solaris-only bugs. And now we've built KDE 4 on top of all of that. So we've got a complete KDE 4 desktop available, which makes, as far as I'm concerned, I mean, I'm a KDE person. I don't particularly like GNOME. I can use it, but I don't, for whatever reason, I don't like it. All of a sudden, Solaris is now a desktop that I can use as a developer because it's pleasant to use. It's got great tools, and it's got the desktop I always wanted anyway. As a consequence, I'm now using Solaris as my main development OS instead of FreeBSD, which it was previously. So that's sort of the gist of my talk. You've got great developer tools. Convincing free software developers to use them takes a little doing, but you know, get some enthusiasts like Roman at the right place at the right time, and you will trigger some people to switch and start using the tools. And yeah, then you've still got a long way to go to get sort of the masses to apply the tools as well. And well, my personal experience here is that, okay, I get the feeling I've now mastered the use of some of Sun's developer tools. I can manage all the neat stuff that Studio 12 throws at me, but there's still this gigantic heap of other free developer tools that Sun produces that are underdocumented and undervalued by the free software community. So this morning we were trying to hunt down some really peculiar bug with signal handling. And Roman was like, oh yeah, here I can do pstack. And pstack is this mind-blowingly cool thing because it prints a stack trace of some process over there. I didn't know that existed. Okay, maybe I'm just a lousy developer. That's possible. But all of a sudden, this whole new vista of debugging possibilities opens up for me. And, well, someday I will hunt that bug down and kill it. And that'll probably be thanks to the Sun developer tools. So, any questions about KDE 4 or why do we do this? Yes. So the question is Studio 12 strict on C the same way it is strict on C++? I don't know. I would have to walk over to Roman and ask him. Simply because I don't see a whole heck of a lot of C code and I don't worry about what Studio 12 is complaining about when I do see C code. Roman, what do you say about?
C is a well-established language. I cannot really say much about C prior to C99, but what I can say is that Sun Studio on Solaris gives you a full compliant C99 environment. And I don't think that you can still get the same level of compliance on Linux because of the things that might not necessarily even have to do with compilers. So the implementation of bits and pieces of libc and libm, as far as complex numbers are concerned, is not C99 compliant. In that sense, I would say that Studio is pretty strict, and it seems to be not really. So basically, it seems to be not really at the level that you can get from tools like lint. That's why we still have lint as a separate tool. But it is definitely much more stricter than GCC, even when you specify like -w all and things like that. Again, not necessarily because of sort of GCC and Sun Studio like compilers being worse or better, but because of the platform itself as well. I also don't know whether GCC on Solaris, where C99 compliant libm and libc are available, is C99 compliant or not. That I don't know.
Anything else? At the end of this session, I'm going to sit down and actually use this sucker to compile KDE 4. It'll take about 6 hours, but Dennis.